And thanks for watching my latest video of revision. In this video, we're going to be looking at the physical and human fieldwork we undertook in preparation for the Paper 3 exam. This and the pre-release video both need to be watched and made appropriate notes from to really get the most out of it. So my advice would be, as you're watching this video today, have some flashcards or have some notes ready to take down key points. And please do pause the video whenever you need to read through the key information or to revisit anything that I say. So on this exam, you're going to get asked questions about your physical and your human fieldwork. Now, our physical fieldwork asks the inquiry question, to what extent is the Ainsdale Sand Dunes Nature Reserve a typical sand dune ecosystem? You may have to regurgitate that inquiry question in the exam, and as long as it is as close as possible, you'll be absolutely fine. Now, Ainsdale Sand Dune is we're trying to prove is a typical sand dune ecosystem. And the hypothesis that we came up with was that the amount and type of vegetation increases the further away from the sea. So the further away we go from the sea, in theory, should lead to the increasing amount of vegetation and the amount of biodiversity as well, the number of different species of plants and animals. And we'll go through that as we go through the video. This is underpinned by some geographic theory. Now, the idea of longshore drift and sand dune succession are throughout the specification, and sand dune succession theorizes how vegetation changes across a sand dune. Now, we chose Ainsdale as our location because it was appropriate. Now, it was an appropriate location because, firstly, it was a fairly close distance to our school, so we could collect enough data within the time frame of the school day. It also had an appropriate footpath that led to the sand dunes to reduce the risk of injury. There are literally thousands of transect lines we could have done, and we chose this particular one because there was a car park nearby and a footpath which allowed us to enter the sand dunes as safely as possible. Now, before we began our investigation, we started looking at different types of sampling. Now, there are three main types of sampling: random, systematic, and stratified. And what we did was something called a systematic sample. We drew a transect line from the beach all the way to the back of the sand dunes, and we took measurements every 50 meters. This is good because it is quite quick and easy to make, and it covers the whole study equally, but not all sites have an equal chance of being selected, and also there may be over or under representation of a particular feature. I'd also say as well that this is very difficult on the sand dune due to the different obstacles in place. Now, when we got to Ainsdale, we completed 4 different primary data methods, and this is data that you collected yourself. Now, of each of these 4 methods, there are pros in the green and cons in the red. So the first thing we did at each of the 4 sites was we used a quadrat to estimate the percentage vegetation cover. So we got that little white quadrat, we threw it down, and you guys estimated between 0 and 100% how much vegetation cover there was. Why was that good? Well, it was easy and quick to collect that large data sets, and to reduce bias, you should have thrown the quadrat behind you or thrown it at random to reduce that bias. However, the problem with that vegetation survey is that the estimation can be very, very inaccurate. What I would say would be 98%, you might have said was 96%. That's only a small difference, but obviously in the world of science, that means that someone's data isn't accurate, which means that the conclusions can't be valid in the long term. The second piece of data collection we did was the biodiversity survey. And what we did at each of the 4 sites was we had a species checklist, which had things like marram grass on it, which had things like limb grass or lime grass, and you ticked off which species were at each site. Again, very easy, very quick to collect large data sets. However, not all species were easy to identify, leading to inaccuracy. it was very difficult to determine some of the different species, which could lead to inaccuracy, but also as well, um, not all these species were actually on our survey. We went during winter, and therefore, a lot of the species that we should have seen weren't there. We'll come back to that later on. The third method we used was the wind speed method, and we used an anemometer to measure the wind speed. That little yellow tool with a little fan on it, we held it into the air for 5 seconds and then read the results. We held it into the air for 5 seconds to try and make sure that the gauge was balanced. Now, what this is really good was that this was quite specialist equipment. So we're assuming that the actual accuracy of the wind speed was really, really good. And also, as well, it helped us determine how the weather affects the sand dunes as well. However, the problem with this method was that we were all very different heights. And so we were all measuring different speeds in the same site. I'm 6'4" with my arm up in the air. If it's higher, it might be windier where I am than where one of you guys were at a lower height. And the reason why that's inaccurate is because if somebody else was trying to repeat this investigation, they would get different results based on how high up they held the wind speed survey. So not particularly accurate there either. And then finally, we also tried to do some field sketches at each site. This helps us identify key features like dune slack. It helps us add additional information to our features. However, the weather, like the wind, made it really difficult to complete accurate sketches, not ideal overall. Now, with all of these things, in theory, to improve our reliability, we did class averages. So rather than just taking one student's results, in theory, we took every single member of the class to create a class average that we then recorded. And that would then, in theory, reduce the inaccuracies as it would discount any anomalies in the data. This is an example of a field sketch, which we should have done. This is obviously a photo and a field sketch as well. And they are really, really useful in identifying things that maybe other methods can't. But it wasn't just primary data that we collected. We also used secondary data, and that is data collected by somebody else. Now, one of the big things we did was we went on Google Images and photographs, and we found images of these sand dunes, and we annotated key features. What that was good for was it helped us identify things that we may not have seen when we went in those sand dunes. But more importantly, we also use Google Maps as well. So I put on your Fieldwork booklet a Google Maps satellite view of the sand dune, and this helped us in lots of different ways. It helped us with the location of the sand dunes, so working out how to get there. It helped us to produce our transect line, so we could use GIS, Geographical Information Systems, to look at the sand dune and overlay a transect line on top of that as well. And by adding those things together, that gave us a bigger picture. Now, in the exam, you should know the strengths and limitations of both these types of data, because it could quite easily be a 6 or a 9 marker, asking was your primary or your secondary data better. Now, usually primary data is better because it's the most up to date. You know it's specific to the inquiry. You know that the data is reliable, and you also know the method of data collection. However, time-consuming, mainly specialist equipment, and the sample size needs to be really, really large. Secondary data, however, easy to access, usually low cost or free, large amount of data sources are available, and add in there as well, it shows you things from the past as well, which you can't see. But the data may be out of date, the data may be biased, it could be filtered, it could be wrong, and it's not always specific to the inquiry either. We have to match it together. Now, in fieldwork, what you need to do after you collect the data is you need to present it. Now, we collected the data in little tables, didn't we? We recorded the vegetation percentages, etc. And we did the following. So, to show the biodiversity survey, and that biodiversity survey was the different species of plant and animal, different species of plants in the sand dunes, we created a kite diagram. And the kite diagram, if you remember, did basically a line to show how much of each species was found at each site. Now, if you're not sure what a kite diagram looks like, I'd advise Googling one because I haven't included it on this video. But they're really good about kite diagrams. You can track change over a distance. So because we were going over a transect line, we could see how the vegetation changed from the shoreline right the way back to the back dunes. It allows us to make easy comparisons, and it allows for valid interpretation to reach valid conclusions as well. However, they're really time consuming to construct. They're difficult to construct, so can lead to errors, and the interpretation is coming from estimated results as well. So really, the scale that we choose, they took ages to draw in class, if you remember, not a real positive of this method. We also made a scatter graph of the different wind speeds. And again, we can identify anomalies more easily. They're easy to construct and interpret. They allow comparison, so we can determine the presence of a correlation. However, they only ever show two variables, and it only gives a broad or a rough idea of correlation as well. You need a statistical method as well to calculate the exact correlation, because that line of best fit may be based on inadequate data. Now, following the stages of our fieldwork inquiry, we then came up with some conclusions, and the conclusions are listed here. The further from the sea, the greater the amount of vegetation. The further from the sea, the greater the number of species, different species of vegetation biodiversity. This is a typical sand dune succession, aside from the human influence. If you remember, it was a typical sand dune succession, apart from the final stage, where it should have become woodland, but instead humans have built over it and created a car park and a pontoons as well. And where there was a dune slack, that's when we got up and over the sand dune. There was low wind speed, and that would aid the growth of vegetation. However, we have to be really honest with ourselves here and ask how valid were our conclusions. Well, on the one hand, they were fairly valid. We collected a large data set using multiple methods. Our data allowed us to answer the hypothesis, which shows that the vegetation did change the further away from the sea, and we did a combination of both primary and secondary methods to make the conclusions more reliable. You could also add in there that we made that class average to ensure that any anomalies were taken into account and discarded. However, human intervention meant that we could not see the final stage of the sand dune succession, so the hypothesis was not met. Our sampling system was grossly inaccurate due to obstacles like vegetation and sand. We only collected data on one day. Is that representative of the whole year? If my inquiry question is asking if it's a typical sand dune ecosystem and I only visit the location on one day, what about the other 364 days of the year? If we'd gone in summer, the vegetation may have been higher. So we are only going on one day is never a good thing. We also looked at one weather factor as well. The weather on the day had a big influence. It can change very, very quickly. So I would argue that while we did our best, our conclusions were somewhat invalid. But we need to recognise that there are lots of things we could have done to improve our fieldwork and make our data more accurate and more reliable. Firstly, we could increase the number of visits. So we could visit during multiple times of day or year. So maybe we could identify the summer species as well to gain a more representative data set. Generally, the more data you have, the more reliable your investigation is. We could also have increased our sample size. So rather than only doing 4 sites, why didn't we do 8 sites? Or rather than doing 1 transect line, why didn't we do 3 transect lines? All of which would increase the amount of data we collected, which would make our conclusion more valid. We could also have done extra training on the methods, like the anemometer prior to the visit, to increase our accuracy. So we could have all spent some time training on each of those methods so that when it came to doing it, we were really hot and knew what to do, essentially, to reduce the errors. However, even this evaluation is a little bit far-fetched, because if we're saying to what extent could we improve our field work, we talk about all those bullet points in black there, but actually, do we have the time to do it? Would we be allowed to leave school for 5 days of year and miss English, maths and science and whatever else it's going to be to go and geography field work? Do we have the resources to do it? Can we pay for the teachers to leave for that long? Can we pay for the equipment that we need to make it more accurate? Do we actually have the money to pay for the coaches that take the students to the fieldwork? Because the coaches themselves are really expensive. If we were going 4, 5, 6 times a year, would that be appropriate? Probably not. So there are limitations to how much we could improve our fieldwork. So this is an example of one of the type of questions you would get. So it says, write the title of your physical geography fieldwork inquiry, and it asks you the question, suggest why one set of data you collected in your physical fieldwork inquiry may not have been accurate. 2 marks. So for this, you would have to give a mark, a reason why it was not accurate, and then fully explain it. I'm going to give you a chance to have a go at this question yourself and pause the video, and maybe look back at some answers, and then we'll move on. So there's lots of different things here. These are obviously more generic, but you can notice here, if you just write poor sampling, for example, you're only going to get 1 mark or not enough data. You need to make sure you're adding that extension on. So, or this meant that, this meant that. The other type of question you could get is looking a bit more at a longer answer question. Assess the effectiveness of your data collection methods. Now, for this exact question, it's basically saying, why was it effective? But also, why was it not so effective? Okay? So why was it effective? Well, there's loads of reasons there. Appropriate data to meet the inquiry question. The method contains numerical data, which enables a statistical analysis to be carried out. The methods allow for visits to several sites. Selected the match equipment available. Sampling strategies were planned. Methods chosen allowed accurate measurements to be taken. Loads there. Why was it not effective? Well, the weather conditions may impact on your ability to measure and or record data. Data collection methods, such as systematic sampling, could be affected by a lack of accessibility to the site. And also, our data collection methods, systematic sampling, could have been affected by a lack of accessibility to the site. Ours failed due to a sand dune acting as obstacles for the transept line. Now, for this question here, you can also bring in your own information, such as these things here. So these are the pros and cons of each method. If we go back, you would bring in as to why your methods weren't that appropriate, really, as well. Okay, so for this question here, for this information here, I would use that to answer large parts of this question here. Okay. The other type is looking at the 12-mark question, the 9 plus 3 SPAG. And it says, for one of your fieldwork inquiries, so physical or human, assess the extent to which the accuracy of the results and the reliability of the conclusions could be improved. Now, for this question here, it's literally just this part here that we've just gone through. So what I would do for that 9-mark question is, I would go through a couple of things we could have done to improve our accuracy and reliability, and I would have given this counter argument, this but do we have the time to answer that as well? So it's really important that you actually do each little bit of the stage, because each stage will be either a 6 or 9-mark question. So for this question here, if you want to have a little think about it yourself, what you would answer, this is what I went for. Loads of ways we could improve the accuracy, loads of ways we could have improved the reliability. However, if we're assessing the extent, so we have to say there's limitations to what we can achieve. We only have limited curriculum time, the trips in school, money for coaches, specialist equipment. Okay, and that's obviously using the physical geography fieldwork. You could have done the exact same for the human, by the way. But please notice there that there is a 9-marker about evaluation. There is a 6-marker about your data collection methods. There is a 2-marker about your data collection methods. Any of these sections, so the inquiry question, the hypothesis, the appropriateness of the site, the sampling, the data collection, the secondary data collection, data presentation, conclusions, validity of conclusions, and evaluation, all of those could be the questions, basically. So you need to make sure you know them inside out and rewatch parts of this video if you need to make notes. Okay. Second then is our human geography fieldwork. Now, this is when in the afternoon we then went to Liverpool and we said, to what extent has urban regeneration in Liverpool had positive social, economic, and environmental impacts? Now, what underpins this is that we thought but the £1 billion regeneration project will have improved the socio-economic and environmental aspects, and this is due to the positive multiplier effect. So we actually thought that £1 billion Albert Dock Liverpool One project would actually improve the area, and because of multiplier effects. So why did we actually choose to go to the Albert Dock? Well, firstly, it was the site of a £1 billion regeneration project, which allowed us to answer the inquiry question. And secondly, it was an appropriate distance from school, so it allowed a large data set to be collected within the school day. However, it wasn't fully appropriate for us to choose this site, and no site is perfectly appropriate because there's always going to be some element of risk. It was really busy around the Albert Dock with pedestrians, with cars, and all of that is a risk to people's health, isn't it, with injury, etc. So even though the Albert Dock was really appropriate in some aspects, in other aspects it wasn't really an appropriate site to choose because there's elements of risk as well. Now, the data collection we did at the Albert Dock was different to the data collection we did at the beach. Now, to get the 4 sites that we collected data from, in theory, what I did prior to the investigation was I divided the area into grid squares, and then I chose 4 grid squares at random, and that's what we used as our sites. Now, that was a good method because it helped to remove bias, but I had to do it multiple times because some of the squares it was suggesting were unsafe. So one of the squares it pulled out in the sampling was right on the main road. So we decided to move that slightly for student safety. So the random sampling wasn't perfect. Now, the first method we did at each of the 4 sites, if you remember, was the pedestrian count. We counted the number of pedestrians that walked past at each site for 5 minutes. This collected really easy and quick large data sets, and it showed the dock popularity, which helped us answer our question about the economic and social improvement. However, there were some downsides. Some people may have walked past twice, leading to inaccuracies, and also it's really hard to define a pedestrian. So, for example, some of you, when you saw a woman and her baby walk past, counted it as 2. Some people counted it as 1. So there are some inaccuracies there. We also completed an environmental quality survey, and that's basically where at each location you were scoring things on the environment between +3, which is really, really good, and -3, which is really, really negative. Again, dead quick, easy, large data set collection, allowed environmental factor data collection, which helped with our inquiry question, but it is highly subjective. There were some examples where I was asking you guys if you thought the buildings were attractive, and some of you were saying, absolutely, +3, it's a really gorgeous area. And some of you were saying, no, I don't like it, I'm going to give it a -1. So these are very, very subjective. They're based on opinion, which can influence the reliability. But also, as well, the categories weren't detailed enough. So there wasn't enough description on each one, what classed as good or bad. So we could have added the amount of description. There was also missing factors as well, like water quality. We couldn't really measure either. Again, to make this more, if we were going to the evaluation, we could have made a class average, couldn't we, to improve it? And the last thing we did was a land use survey, and that's where we walked around the Albert Dock and we shaded in the different things we could see, like the retail, like the shops, like the restaurants, etc. as well. It allowed us insight into economic activity and a large data set of the whole dock area. It's a bit more representative of the docks, but the survey was only on the ground floor. So we had a fairly incomplete data set, as the docks do have actually a second, third, and fourth floor as well. So we only actually covered a quarter of the dock area. So was it that representative? Representative, really? Probably not. We also, again, did some secondary data. And one of the main things we used this time was the Google Images photographs. Now, these were really, really useful because it allowed us to see the area before regeneration. We couldn't do that on our primary study. So we could actually see what the dock looked like before, and then we went and saw it in real life, which is really, really useful. However, the pictures we did see on Google were heavily edited. It had the shimmering blue waters, the docks had the really red poles, when in reality that's not really the case. So they give quite an inaccurate view. We also looked at the Albert Dock official visitor numbers. It provided us some quantitative, which is numerical data that we were unable to collect ourselves. So we couldn't find out how many tourists visit every year. We went on one day. But the data only continued to 2019, so it was quite out of date, 4 years out of date, actually, that data in the end. So there's that point on sampling. So we use random sampling. We divided the dock into grids using an OS map. We pulled out 4 grids out of a hat to determine the site locations, but the sampling is not 100% useful as some sites it chose were dangerous, so not particularly good. So what were our conclusions? Before we get on to the conclusions, actually, I want to go through the data presentation. Now, for each of these things, the pedestrian count we presented on a bar chart. The environmental quality survey we did on a radar chart, if you can recall doing that. Now, radar charts are really, really useful because they allowed quick comparison between each site. If you imagine trying to look at all 4 environmental quality surveys, trying to compare it, it's a nightmare. You draw out 4 radar charts, comparison is really, really easy. It also quickly allows you to identify any anomalies in your data that you maybe wouldn't see on a table view. But radar charts can be quite confusing if they're drawn inaccurately. And it didn't show us any reasons for the differences. They were also based on subjective data, so not necessarily the most accurate anyway. Now, what were our conclusions then? Well, we concluded that regeneration has had clear economic and social benefits. There was evidence of economic activity throughout and limited evidence of social challenges. The environmental area has been improved in comparison to the secondary data we saw. There is less dereliction as a result of regeneration. It was a busy tourist site, so the water and air pollution was quite high at some sites, and the environmental quality was strong in some sites, but not all. Again, similar with the physical fieldwork, how valid were our conclusions? Well, I'll let you have a read through, but the main issue, again, we had great multiple data sets, large data sets collection, more reliable. We only visited on one morning. We need more data. A lot of the methods are very subjective, highly based on opinion. They'll make it difficult for those conclusions to be reached a second time. The criteria on the environmental quality surveys was limited. We had no section for water quality, which would really have helped out when we're looking at the dock area. And the data collection was only in the morning as well, on a weekday. Is that the best time to gauge the popularity of this dock area? Evaluating it then, well, it's the same cons as last time, but we could have increased the number of categories on our environmental quality survey. More data equals more reliable. We could add descriptions for each category to reduce subjectivity. We could collect data at more than 4 sites. Maybe we did 8 sites instead. Maybe we could have collected data at 10 a.m., 1 p.m., and 3 p.m. to give us more comparable data. We could repeat the fieldwork on a different day and average the results. And we could include a multi-level land use survey. Again, the more data we collect, the more reliable it is. However, same as last time, the problems here are, is this actually realistic? Are we actually going to be able to do all this stuff within the constraints of time in school, finances available, and curriculum time as well? Not really possible. A lot of things we could do, but only to some extent because of those factors. So the next question then asks us to justify the use of one of the following in your human geography inquiry. And I went for maps and photographs here. So the first one was the maps to compare different sites to show similarities and differences at each site, which link back to the original aim or theory of the inquiry. Or the photographs down here, the secondary data which shows us insight into the Albert Dock in the past, which allowed us to compare regeneration before and after, which allowed us to answer the inquiry question. So you're slowly following it through, you're spelling it out to the examiner exactly what it is you are getting at. Now, obviously there are more things we could do in terms of answering questions. Another question, a 12 marker, could basically say to what extent were your conclusions valid, at which point you would add this as one section and this as the against section, and therefore you would say it was valid to some extent, but not to a full extent. They could ask you questions about your primary versus secondary data. They could ask you questions about why the site was and wasn't appropriate. And also, you need to make sure you have that inquiry question written down in full. The other thing to point out as well is that you need to be very aware on how we presented our data and why. So again, to go back to this, you would want to look at your kite diagrams as an example of the biodiversity, the scatter graphs for the wind speed. Then for our human inquiry, we did those radar charts for the environmental quality survey, and we also made bar charts for the pedestrian count. Now, whenever the presentation method, it's always going to be that it allows quick comparison, it allows anomalies to be clearly seen, and it also makes the data easier to be interpreted. So whatever the method, it's going to be trying to make the data easy to interpret. It's going to be trying to make the data easy to compare and to identify anomalies regardless of what that data set is. Okay, so thank you for watching this video. It's only a little short one for this paper. Again, if there's any bits you want to go back through, my advice would be to once again go back through them and make some notes on each section, and make sure you also watch the other two videos. There's one on unseen fieldwork, which looks at all the other aspects of fieldwork, and there's one as well looking at the paper 3 pre-release on the Cayman Islands. Thank you.